Welcome to this week's episode of Automated, our podcast where we talk about robots on a somewhat regular basis. I think this actually might be the second week in a row we've made a podcast in some time.
Yeah.
Yeah. Well, I, of course, am your host, Stefan and Ilia, CEO and co-founder here at Polymath Robotics. Sitting across from me is a generic Polymath Robotics employee wearing a generic Polymath Robotics t-shirt and a smartwatch that he's incredibly proud of the battery life for, because for weeks and weeks and weeks, it won't tell him anything interesting or even move. But the battery never needs recharging.
That's just because nobody calls me. But I think we did a t-shirt swap from last week, where last week you were wearing the Polymath one and I was wearing the YC one. Yeah. Our wardrobe is expansive
yes.
and interesting.
I mean, as roboticists, we mostly think about fashion.
Oh, yeah.
That is why if you come to the Polymath headquarters, you'll be overawed with just a sense of glamour and glitz. It's like Emily in Paris, but a lot sweatier.
And our air conditioning was working. Speaking of which,
I thought I could keep it on.
Nope. Yeah, this is why if you're a really good roboticist, your clothes is arranged by stack sort. And if you're a bad roboticist, your clothes is arranged by heap sort.
This is, of course, our podcast where we talk about robots. We spend the first section playing a game with a website that I don't have pulled up. Maybe
I have right in front of me.
And then,
all right.
Well, I have to operate it so I can cheat. I mean, I never cheat. This is highly important. But first, we play a game where we make up a robot. And then we talk about a topic in robotics. And Ilia, what's the subject we're going to talk about in robotics today?
We're talking about the commodification of specifically industrial AMRs, autonomous mobile robots.
I.e., if you can be really good at hardware, it turns out China can just beat you.
Yep.
All right, so let's start off with our game. All right, so we used to draw cards, which were really just pieces of paper that had been cut up. Then for a while, I was reading off a list that a listener had emailed us of technologies and business cases and making Ilia pick a number. Ilia got so bored in some call. I want to say a sales call where I was just waving my hands for...
I think we talked about this last week.
45 minutes. We're repeating because some people skipped an episode where he coded up in Python a robotic startup simulator. And yeah... I think this one could be interesting, but I'll have to find a way to make it a wacky robot.
All right.
The generated technology is test automation to smart cities.
For smart cities. Okay.
Yep.
Okay.
Now, here's what, the point of this, to remind my co-founder and the listeners, is for not a real robot.
Yep.
So A/B testing traffic light patterns to make it so people can navigate town more efficiently.
Too boring. Too real.
Yeah. Too close to reality and yet too sadly not deployed.
Yeah.
Almost certainly not deployed anywhere. Could be something that a team could whip out with with the right infrastructure in a couple of days.
Yeah.
On the other hand, though, we need to come up with a robotic test automation with, again, robots that move through the world.
Yes.
Not just changing sensors.
Yeah.
Not doing RPA for smart cities.
All right. What annoys you about San Francisco?
So many things annoy me about so many things. You know what we could do? We could do some sort of robot. So a friend of mine has a company that tests the energy efficiency of homes and then does retrofits for homes to be more energy efficient in northern states where heat efficiency means, environmental blah, 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 blah.
Okay.
I think we should do that automatically. Now, the problem is winter only comes once a year and summer only comes once a year.
Right.
So if we want to test someone's insulation, we should be able to alter the climate around their house on the fly to see how easily their system can adapt. And what the benefit of this is, you could then A/B test individual days. So if it's a warm week, you could say, here's what their heat usage should be for the rest of the warm week. Now let's make Wednesday really, really, really cold locally to them.
That's right.
To test the efficiency of their heating.
It doesn't matter that you have to build a house-sized refrigerator or heater. That's not.
Well, I'm thinking this is more a series of mobile robots. So to heat up a house, for example, it could be a series of quadcopters with a giant magnifying lens.
Yeah.
That just shoots heat, funnels heat from the sun into people's houses to warm them up to see how good they are at air conditioning.
And if you don't pay your energy bill, the focal point of it drifts a little bit higher. just to like slowly set your house on fire. No, you know what the real target for this is? It's PG&E, who sends you those bills that say efficient houses in your neighborhood use this much power.
Yes.
Which fun side note. I recently learned that they'll send this, and the number that they'll say, like, efficient average houses in your neighborhood,
25th percentile.
It's so much lower, it's not even funny. It's like fifth. And the reason why is because they do no effort to filter out houses that have solar panels that take up the massive amount of their actual energy usage. So they're like, look at Bob down the street. He used negative 10 kilowatts last week. Why can't you use negative 10 kilowatts? It's such a stupid system. Like, it's so dumb.
Listen, that much data science is beyond the grasp of the great mathematicians at PG&E.
I mean, they couldn't possibly do outlier filtering on their data set. Like, that's not reasonable. It's not like they know you have solar panels because you're mandated to tell them.
So we want to heat up homes or cool them artificially, or actually
with robots,
or even honestly whole buildings.
Yeah.
You know what we could do with the buildings? We could have we don't have to like do a death ray or refrigerate them. We could just have robots that block off their HVAC exhaust.
But then you're not really, because the thing is, like, in classic robotic fashion, you could do a lot of difficult, complicated robots here, or you could just do the thermal equations of delta temperature from inside to outside.
We need a mechatronic device.
Yeah, exactly. So, classic robotic solution. But like, if you actually want to test your full house, you don't really want to block just the HVAC. You want to like actually test the house.
Well, I'm thinking like if you block the heat exhaust from the HVAC, suddenly your HVAC is just a heater.
Yeah, and everybody inside dies of carbon monoxide poisoning.
That's a minor. You're getting stuck up on details. We'll solve that after we get a productization.
Okay. Just to be clear, right? No, but like, have you ever seen modern furnaces?
Yeah,
they're unbelievably efficient at heat capture. Like the exhaust from a furnace is like 5 degrees warmer than ambient. They're so ridiculously efficient. You'd get such a small difference.
See, my furnace is from the 70s.
Yeah, exactly. Like
I would be surprised if the manual for my furnace has like non-PC words.
Modern, like even and tankless water heaters too.
Yeah.
Like the exhaust from a tankless water heater is barely warm.
Well,
it's
so
ludicrous.
actually what we could just do is a robot that brings a heat source into a building.
So a pyromaniac robot.
It
goes
fire,
in and sets random things on fire.
A fuel rod. Yeah.
A uranium fuel rod. So we're back to this now.
Yeah.
Okay.
So like it's like a dog robot that brings in like a fuel rod at like 10,000 degrees Fahrenheit, and it sees how effective your air conditioning is at cooling that down.
No, I still think like actually a swarm of robots that just self-assemble panels around your house to then turn it into a greenhouse or a freezer. I think that's like...
And you actually wouldn't have to cover the whole house. Probably just a couple of windows would create enough extra heat that you could raise the temperature by a couple degrees.
Or cool, right? Because a lot of windows actually act as heaters. Yeah. So, yeah. Just come in, little quad rotors that come and stick reflective foil on your windows.
Yep. Boom. All right. Here we go. So we target houses with sunroofs.
All right.
Right? Because then they have or sunroofs or Skylights. So they have a window facing the air. Then we have a fixed wing drone that deploys a series of quadcopters. The quadcopters each have a corner of a reflective sheet. Yeah. Land on the skylight. Yep. And that probably would increase heat by a couple of degrees.
Or decrease it.
Yeah.
Yep.
And then we just measure it that way.
And then what do we learn from our measurement?
How efficient they are at heating or cooling.
How quickly we can waste VC money.
Listen, we're using these systems to get data for a foundational robotics model.
Foundational heating model.
Yeah. And foundational heating model.
Yeah.
Like when we get all the data from the grid about how this affects heat, we will use AI to find a way to more efficiently heat the grid.
We will spend $30 million of VC money handed directly to NVIDIA to learn that when you increase temperature, the temperature goes up.
I don't think $30 million is enough. So we can have our loitering fixed-wing drones fly over, drop off a couple of quadcopters. Yep. We don't have to tell people that we're doing this if it's a skylight. Cool. Like we can just do it sneak attack. And measure.
Surprise! Robots drop out of the sky and just cover your windows.
I heard that's popular in Eastern Ukraine.
I feel like
robots dropping out of the sky.
I feel like I've had a nightmare like this. Something out of Terminator.
So realistically, for a fixed wing system like this,
so you need at least 2 quad rotors. I recommend each pair of quad rotors is called Cheech and Chong.
Okay.
It's because we're hotboxing the house.
Yep, that makes sense to me.
All right, important naming done.
And like, I don't know if they named in one of the Cheech and Chong movies, they have like a van with like a tiny little steering wheel.
Yeah,
like whatever that van is, that's the fixed wing.
That's the command structure.
Yep. So fixed wing, like, that's probably a $50,000 drone.
Yeah.
You know, a neat thing is the quad rotors don't necessarily have to go back to the fixed wing. The fixed wing could just go back to an airport to get new quad rotors.
That's right. Disposable quad rotors. You wanted them to warm up the house, right?
Well, no, the quad rotors, after they warm up the house, could just fly to the nearest PG&E van.
And set it on fire? I'm trying to understand.
No, I'm thinking like after their mission's done, one of them releases the fabric, the other one like rolls it up. And they fly to the nearest like PG&E spot.
Biodegradable reflective film. You put it there, and for an extra fee, we'll spray on the biodegradant so it degrades a little faster.
For an extra fee, PG&E person will show up for sometime in an 8-hour window during your most important work day to remove the film.
Yeah, exactly.
But like each of those quad rotors reasonably could be a $500 quad rotor.
Yeah,
you could do some of these like shading. You could probably do like 20 of these shading missions a day.
You know what would be the hardest part actually? Probably determining. Oh, maybe not. If you're talking specifically skylights, determining how to detect and cover a skylight.
Well,
you could do that from maps, though.
Yeah, you do that from
satellite maps.
Yeah, so you just buy satellite data. You train a model on skylight, no skylight, which you don't have to
probably actually get pretty accurate.
Yeah. Like, you could be that's a relatively straight. I mean, there are tools that do this for determining suitability for solar installation.
Yeah.
Yeah. You might need some local intelligence on the quad rotors to make sure it's actually a skylight, or to make sure they're dropping it on the skylight.
Yeah.
Well, it's actually like thinking about what the quad rotors need to do. What's kind of the state of the state with 2 quad rotors flying essentially a string or a cloth between them?
So it's actually, what would I call this? Like cable kinetics is actually a fairly difficult, surprisingly difficult problem.
It's not a cable though; it's a cloth.
Whichever, right? I think we figured this out actually at the dawn of the space age, where they wanted to do tethered spacecraft, and in zero gravity, this is not, but it's close enough if you're flying around. It's surprisingly complicated to get a tether that is taut but doesn't snap and doesn't pull the 2 objects together.
That's a hard controls problem. It's a big cost if you screw it up.
Surprisingly difficult controls problem.
Yeah.
So I would call 2 quad rotors stringing a arbitrary line actually fairly difficult.
Well, what if you made one of the quad rotors bigger, like Big Brother, Little Brother?
Yeah.
Big Brother did all the flying on the way down.
Yep.
And Little Brother just hung off Big Brother's belly.
So to count, we have a deployment fixed wing that deploys a quad rotor, that deploys a smaller quad rotor.
As we always say, to make your robot better, add more robots.
I think at this point, the name of the project has to be Xenomorph, because like there's no other option here. It's like the little mouth pops out of the big mouth.
Like what evolutionary advantage?
It's Geiger. What do you want?
Well, I mean, you actually could just do away with the big fixed wing. Given that there are PG&E places everywhere, or at least there's a massive one in my neighborhood, like you could just do a normal quad rotor. But going back to
this will result in a new complaint. One last side note. There will be people in San Francisco who complain about living near the parking lot for the Google vans that beep at each other.
Yep.
You'll be living near a site that just has droning quad rotors 24 hours a day. It'd be great.
I think a lot of people will be complaining that their skylights are now covered with the film that has stayed there for 4 weeks.
It's fine. Just pay your bills and they'll come off.
If the smaller quad rotor just has to do these dynamics, relatively short distance, relatively close to a surface, it seems like that would make it.
I think the trick you do here is you make the cable not a rigid cable, but you make it a spooled retractable cable.
Yeah.
Like a dog leash.
Yeah,
exactly. Okay. That was super helpful for our podcast people. Stefan made a noise and a hand gesture. Great. Okay. Imagine what Stefan put.
It was more polite than my normal hand gesture.
Yeah, exactly. Yeah, no, but like if you had kind of a dog leash type retractable spool, and then the little quad rotor's control algorithm is basically fighting to keep a constant tension on that spool with a little tension meter.
What actually would it have to if Big Brother just went to one end of the skylight, and Little Brother just flew towards the other, and like when it got to the other, it released and dropped the film on top.
Yeah.
Now that means like the film is dropped on top and you can never get it off until you pay PG&E $400 for someone to come. But hey, we've tested their environmental efficiency.
I think you embed little magnets in the film,
Mm-hmm.
and then the quad rotor just has a magnetic hook on the bottom that just swoops over, it grabs one, and off you go.
Just to add more things, now the robot should come into contact with people's glass skylights.
Yeah, of course. If it fails and falls out of the sky, you just have a much higher local thermal increase as the lithium-ion battery explodes.
I'm imagining someone sitting in their house having a breakfast. Suddenly the room gets dark, and then like a $10,000 loud robot with blades falls through the ceiling. It's like look up from their orange juice. Like, geez, this is gonna be like a 6-week insurance claim. Terrific.
And the real answer will be still not the worst thing that PG&E does.
Well, that's our flame starter robot.
Yeah, exactly.
So that's a whole.
Yeah.
If you missed that episode, I don't know. That's an episode that just went to special listeners.
Yeah. All right.
Our gender reveal robot. That's our best one ever.
So beside naming the quad rotors Cheech and Chong, what are we actually calling this product?
The xenomorph system.
The xenomorph system. That's right.
Yeah.
If it doesn't succeed, it'll die trying, or someone's dying trying.
Yeah, and for it, PG&E will have to pay us probably $75,000 per system per year.
Yeah,
not too bad.
Yeah, it's fine.
And they'll get information that will lead to thousands of dollars of efficiency.
Entire dozens of dollars that could not have been solved by basic physics calculations.
Yeah. But our cities will be smart. All right, on that note. So, Ilia, we were having a conversation with someone a couple weeks ago who mentioned that they went to a show and there was just AGVs all over the place. Yep. AGVs for days.
AMRs.
Yep.
Yeah, these are all general terms for like square-ish robot that moves around a flat floor factory or warehouse moving stuff from A to B.
So I guess and we were talking about that conversation when we left, and you had a loud point of like, this is why we're not working in AMRs.
Yep.
So what's been going on? Like, what did the world of AMRs look like 12 years ago when you started at ClearPath?
Yeah.
You're old now.
Yeah.
What does it look like right now?
Yeah. Going back in history a little bit, AMRs in their sort of current iteration started way back when there's a lot of companies that built sort of very similar to ladder logic or the old school PLC controllers, where it was like strap a battery, PLC controller, some motors, put tape on the ground, and the PLC is just looking, if the tape is on the left, go right. If the tape is on the right, go left.
This just reminded me, I was in a hotel recently for some trip and put on random hotel, like actual TV, not like streaming stuff, and watched a new episode of Beavis and Butthead.
Okay.
Where they get a job in an Amazon warehouse.
Yeah.
And they talk about how the machine learning in the warehouse will bring you more of whatever you're packing into boxes. So you just start grabbing spray cheese off of the AMRs and eating spray cheese until the whole warehouse bursts into flames because it's only packing spray cheese.
That sounds about right.
Yep.
Yeah.
Yeah.
So
important thing for me to tell you.
Intelligence.
Yeah.
Early days, very, very simplistic machines and following tape or beacons, that kind of stuff.
Talk about the tape. That was new to me when we first saw someone who was talking about tape.
Yeah. So either literally black colored tape and the robots would have light sensors, or slightly more robustly magnetic tape and it would have magnetic pickups.
Yep.
But otherwise, you draw out tape on the ground. And you can put little encoding information in the tape, like extra little strips of tape to say, stop here, go left, go right, whatever. But basically, it's a slightly more flexible conveyor belt at the end of the day.
Yep.
Works really well for massive industries. Like one of the key things I know a lot of these AMR companies will do is pick up vehicles that are in production.
Yep.
So instead of having a conveyor belt holding the vehicles, you literally have moving robots holding the vehicles. Yep. Because that way, the main benefit of doing it this way is if a particular vehicle has a critical flaw, you can pull it out.
System.
Yeah, you can pull it out of the assembly, advance the rest of the assembly a little bit faster, and off you go. So very flexible that way. The problem with these systems was they were super dumb.
Yeah.
Right? Like microcontroller levels of intelligence.
I think it's useful calling out here that for a system like this, it even if you know that it's just following tape blindly, it looks like it's intelligent.
Yeah.
Because if you're following tape and you have like a 2D LiDAR that tells you if there's an obstacle right in front of you.
At the time, not even LiDAR.
Well, yeah, but
yeah.
But like, or you add this like a safety bumper, it is easy for people to make the leap from like, oh, well, soon it won't need the tape.
Yeah.
And soon it will be able to do whatever.
Exactly. And we were stuck in this like relatively dumb AMR mode for 20 years, 30 years. And what started to change was A, compute got cheaper and smaller, so it became feasible. And B is really sensing like LiDARs and cameras and that kind of stuff became also cheaper and smaller to the point where it's feasible. And so the whole goal of this in the last, let's say, 10, 20 years emerging AMR industry was to replace the tape with a flexible software-defined tape. Right? And so, because tape has its problems. A, it's not very flexible if you have to change your manufacturing process. You got to tear up the tape, you got to rebuild it, and it takes significant time. But B, it wears out. It gets cut, it gets
loses magnetic charge.
Yeah, whatever, right? It fails in a bunch of different ways. So the goal is to have a system that's as robust and as predictable as tape, but doesn't need tape. And so that's where LiDAR SLAM really came into its own in the last 10, 20 years, let's call it, where it can localize reasonably well in a fixed factory environment, in a fixed warehouse. Side note, I don't know what, and I think Kiva's moved away from this, or Amazon Robotics has moved away from this recently, but up until Amazon purchased them, they were using little QR codes on the ground. And the robots would also be relatively dumb, where they had just enough localization and intelligence to get from one QR code to the next QR code, which were about, I want to call it like a meter, 2 meters apart. And if they drifted in that time, they would drift only an inch or so, and then they'd be, or a few centimeters, and they could snap back. Exactly. And it was a grid pattern of these. So again, you had to make sure you had this very, very accurately placed QR code grid that would enable your warehouse robots to get from A to B.
Which also having an entire warehouse size space. That you can then have high precision people install a series of QR codes deliberately over the course of probably 2 months, like maybe 3 weeks, but like realistically 2 months, is something that means only large companies can have it.
Only large companies can have it. And like the really brilliant part that Kiva did was to make the robots as dumb and cheap as possible, to make it just a giant swarm of them. And the large part of their effort was the coordination system, this master control system, which would then tell each robot, okay, advance to the next one, advance to the next one, advance to the next one. And then on top of all that, there's the non-perfect conditions of when a jar of soap falls off one of these crates, which happens daily. And it fouls an entire several meters of the floor, that the system recognizes this and routes around it. And that kind of stuff. So the genius there is a central planning system.
Which again makes sense if it's a dedicated space with only one type of AMR.
Exactly.
And like you can't have people in it.
Correct. Now recently, again, kind of getting closer to modern day, as with all technology, it's getting cheaper, it's getting faster, it's getting more accessible. And so now you can push this towards smaller companies with more flexible spaces, because now the robots are intelligent enough to understand where they are in space. Again, ClearPath Robotics Auto Motors did a lot of effort here to make it super software defined, easy to use. That's why Rockwell purchased them in a lot of ways, is now they have a solution out of the box of here's a very robust AMR system that's flexible enough for even the smallest manufacturer and cheap enough, right? Or effective enough. But now that we've gotten to the point where even cheap LiDAR and computers can do this trick, and there's enough people trained and understanding this, now we've gotten to commodity phase where cheapest hardware wins. Right? Because now it's no longer a trick to see a robot traverse a space. Like a gifted undergrad could pull that together out of Ross in a few weeks. Maybe it's not industrially rated, obviously, but like the step is not that big. And so now you have a billion competitors in the space. Right? And the literal conversation we had with our client was like, we just got back from a trade show, and there was 6 different companies who will just sell you an AMR with all the software, with the compute, with everything integrated for a one-time cost of, let's call it $10K. Like, there you go. Problem solved. Right? And at that point, there's no competing on software or features at that low of a cost. Like, it could have awful software, but if it costs a literal order of magnitude less than the next competitor, hard to beat.
And I think what's interesting in that is that particular company has invested a lot in their own AMR.
Yeah. Yeah. For their particular, very specialized use case.
And I think a common refrain in this market is like, oh, you have to own all of this stuff. And then sometimes, suddenly you don't. Yeah. And suddenly the blood, sweat, and tears and pretty meaningful organizational direction that you've invested into, being a hardware company is suddenly irrelevant. And I think there's also, in general, there's a lot of robotics companies who underestimate how hard it is to fundamentally change what type of business you are. So you go from being like a hardware development lab plus AI lab to being a factory operator, or being just a software company or just a fleet management company. Like that is a pivot where every single hardware person knows that there's suddenly a target on their back and what is the point of their job, regardless of how smart and brilliant they are.
Yeah. Yeah. I mean, honestly, again, we were just talking with another collaborator today, and his kind of comment was, it's very common to see robotics companies get to a stage where they're successful enough that suddenly it's, what are you doing working on the software? Does this increase the bottom line? If it doesn't, you immediately stop.
Yes.
I don't care what you're doing. Yes. Stop it.
Yeah.
Right. It's just a matter of making it more reliable and more scalable and more sellable.
I mean, I remember at Starsky thinking of like, oh, okay, if we can drive autonomously on the highway, that cuts our labor cost by 95%. If we can do a decent amount of surface streets between the highway and the truck yard, cool. That cuts our labor cost from 5% of what it was to 1% of what it was. If we can do truck yards, any random truck yard, any random street level condition, that adds a total of 25 bips to our profit. Yeah, 0.25% to our profit. Whereas if we built better software for figuring out which load we would take, that might add 10% to our profit. Yeah. So true autonomy stopped being all that interesting. And I think that's as robotics companies get closer and closer to being a real business, a lot of the idealism of like, what's the thing that you want to what's the thing that you think you want to build turns into, well, what actually that matters to the customer. Yeah. Which is rarely your perfect hardware, rarely your perfect autonomy.
Yeah. And in some sense, I think commoditization is the hallmark of a maturing market. Yeah. Right? Like that's actually a good thing in a lot of ways, because it means that it's now mature enough that it's not, we've talked about this before, but like, a good definition of robot is
a machine that doesn't work.
A machine that doesn't work. Because as soon as it starts working, it's not a robot, it's an appliance. Or it's a machine. Yeah. Right. So like, the old school Toyota, for example, tape following robots from the 80s, I wouldn't call it a robot anymore. Yeah. Like it's strictly a PLC-driven, dumb machine. Yep. But at the time, it was a cutting-edge robot. Yep. I think we've gotten to that point now for some
batch of it. But what's interesting is like, if you were to start an AMR company today, you probably shouldn't be a hardware company.
No.
You probably like, if I was thinking of, and I've spent very little time in the AMR space. I have spent very little time in factories, but a really cool AMR application would be if you could walk into a factory, scan it around with your phone, create a 3D map, throw kind of any AMR into it, and come up with, a general gist of where the paths should be, and then have smart UI tools to adjust those paths with a bunch of fleet management that quote unquote just works.
Yeah. Yeah.
And that sounds a lot like a software company.
Exactly. Because again, along with commoditization, you get standardization in some sense, right? Like people for robots have been willing for a long time to be like, oh, I bought a ABB robot arm. Yep. I know I have to use ABB standard programming language, period. Yep. But now it's coming out of like, oh, you can buy any one of these 30 robot arms. You better have a consistent language to use them.
We were talking to someone on Monday where they were saying, oh, for robots in their use case, they can't have people in the field interact with them, construction people in the field interact with them. They need an engineer in an office somewhere to build out a workflow in that company's specific workflow language UI tool, which then won't transfer to any other robot that they might use. Which means, frankly, that there are 1/10 of those robots sold than as opposed to should be.
Yeah. I mean, as a very visionary person told you, the hard part about autonomous vehicles is not the autonomous vehicle. It's building a custom programming language to develop on those autonomous vehicles.
I'm so happy to announce that company was Ghost Row Automation, the self-driving car company who announced bankruptcy a year ago. I've been making this joke for 2 years since I met an executive there who told me that the hardest thing was their programming language they made to be more real time than C.
So the lessons, boys and girls, is don't make your own programming language. Yeah.
I mean, outside of Temple C or Holy C.
Holy C. Yeah.
I mean,
Holy C on Temple
language.
OS. Yeah. But other than that, don't make your own programming language. But yeah, no, I think commoditization, especially in hardware.
Well, I mean, still thinking about the AMR space.
Yeah.
So it wasn't that long ago that like some very serious roboticists were starting a new AMR company.
Yeah.
I mean, like Starsky had shared a board member with Fetch Robotics.
Yep.
Melanie, visionary, big deal roboticist. I think Fetch started 2015-ish.
Something like that.
Where like you had some of the smartest people in robotics think, I'm going to go work on AMRs because that's where the real thing's going to be. Incredible social proof that like there's differentiation in the hardware for AMRs, which isn't true 10 years later.
Yeah. I mean, obviously I don't have any insider information here at all, but Zebra's acquisition of Fetch, since then, I haven't seen very much, could easily be wrong, please correct me, use of the actual armed version of the Fetch. It's all been about the mobile base.
Yep.
Right. And so again, the part about the ARM work has always been more R&D heavy, less reliable. But getting from A to B now is a relatively solved problem.
Yep.
Not in all conditions, right? To be clear. But like warehouses and factories, we've got it mostly okay. Yeah. Right. And then that's, I would call that a very smart purchase by Zebra.
For those AMRs, it is mostly OEM provided software.
It is, exactly.
Yeah.
Exactly. And so I think why Rockwell purchased ClearPath or why Zebra purchased Fetch was to add to their portfolio a controllable thing that you buy from Zebra and everything talks Zebra language, let's call it.
Yep.
Right. And same with Rockwell, right? Like you have a one provider solution, which makes sense at the scale they operate when they have to set up, I don't know, let's call it 10,000 factories a year. I don't know what the real number is, right? But like it that makes sense at that scale.
Yep.
Yeah. But to that point, thanks for reminding me. The thing that we've seen now is the goalposts for cutting edge robots that have not yet been commoditized have moved slightly. So I saw a post by Silicon Valley Robotics just recently that Rethink Robotics is back from the dead, which is actually awesome.
Yep.
I'm very happy to hear that. And they are providing an AMR, but also ARMs and the combined unit. And I think the last part is the most interesting. I've been banging this drum a little bit with people who are in the space, but I think machine tending, especially for American manufacturing, is very interesting space. Where
basically robots that feed material from one machine to another.
Exactly.
Or one pile into a machine.
Yeah.
Or one machine into a pile.
If you look at a lot of small machine shops today, the main cost is, the machinery is expensive for sure. The CNC machines are expensive. But as always with small businesses, the main cost is actually labor. And it's very hard to be competitive on pure cost basis. If you're labor, you have to pay labor rates here. And so the goal is if you need to make 100 of some widget, instead of a person standing there and inserting the billet, waiting for it to be machined, taking it out and inserting the next billet, you have a machine tending robot that comes in, picks up the billet and does the thing. And that's starting to pick up more and more and more. And I think they're still hasn't been commoditized because the math to do ARM manipulation on a mobile base in an unstructured environment is still fairly cutting edge. There's lots of safety concerns. There's lots of perception trickiness. The folks who support the Move It package.
Which means they will likely be the biggest companies who get autonomous machine tending first.
Exactly. But it's coming. It's coming. The folks who maintain the Move It package are focused on kind of this problem of moving arbitrary arms through space safely. And I think that's a space that hasn't been commoditized yet. But if you're just starting a company, I would predict you got about maybe 5 years, until that also becomes quite commoditized.
But the hardware or the software?
All of it. All of it, yeah. I strongly suspect. I would put a 5-year bet that in 5 years, machine tending and
I don't think machine tending today, though, is where AMRs were 10 years ago.
Yes, agreed. But I think the pace of innovation has accelerated.
Okay.
I think there's
also things that you can do with like there is no joke AI tools you can use.
Yeah.
Where like what people do on the ground is already only statistically accurate.
Yeah.
It's only accurate within 97% of the time.
Yeah.
So a foundation model for, hey, does this piece look right?
Is starting.
It is about as good as humans do.
Yeah. I mean, Pioneer Fund invested in a company both you and I were pretty interested in on basically this exact premise. And I think those pieces and parts are starting to assemble. The actuation motors have gotten a lot better. You know, 10, 15 years ago, starting a new robotic arm company was unthinkable.
Yeah.
And then I think I would argue, was one of the pioneers of the new generation of robotic arms. And now there's like 30 or 40 UR clones, right? Including, again, apologize, Rethink Robotics, but like they moved away from the serial actuated cable driven robots to a much more traditional UR style arm.
Well, we're about at time.
Yeah.
What are we going to talk about next week, Ilia? Are we going to do another podcast next week? 3 in a row? Is it possible?
Next week or the week after, we're at Mine Expo. So
I'm at a conference Saturday through Wednesday.
Right.
And then we're at another conference next Tuesday through Thursday.
Okay, so we'll see you in 3 to 4 weeks, and we'll talk about what happened at Mine Expo.
We could always do a podcast next week too, Ilia. Just believe in yourself.
Don't.
Thank you all so much for joining us. We'll talk to you soon.
See you next time.